Guys, Mr. Bowman here. We're looking at 2.7 calculus methods in this video, and in particular we're focusing on all the excellence questions from the 2016 exam. So let's get straight into question number 7, and we've got a function with a gradient function of 2x minus a, and we've been told that the point 3, 4 is a turning point. Find the equation of the function. So we're going to first start off by writing down the gradient function. So f dash x is equal to 2x minus a. And we're then going to have a think about this turning point information. So we've been told that x is equal to 3, y is equal to 4. And the idea that it's a turning point means f dash x is equal to 0. So we've actually got quite a lot of information we can use to substitute into this function. So we know that 0 is going to be equal to 2 times 3 minus a. 0 is going to be equal to 6 minus a. A will be equal to 6. That tells us the full gradient function is going to be equal to 2x plus 6. Now, we've been asked about the original function, so what we need to do is we need to integrate to find fx. Just spotted above, that positive 6 is actually meant to be negative 6 because we had negative a floating around above. So just change that. So negative 6. So as I said, we now need to integrate. So that's going to be 2 divided by the power plus 1, x power plus 1, minus 6x plus c. We're now going to simplify that. So that's going to be x squared minus 6x plus c. And this here is our function. So that's the same as saying y is equal to x squared minus 6x plus c. And back to the information that we know above. We know the x and we know the y. We can substitute both of them in, and then we can solve for c. So that means 4 is going to be equal to 3 squared minus 6 times 3 plus c. So 4 is going to be equal to 9 minus 18 plus c. C minus 9 is equal to 4. We're then going to go plus 9, C is equal to 13. And when you've got that, we know that our function, fx, is going to be equal to x squared minus 6x plus 13. If you get all the way to the end, that's what will get you an excellence mark for this question. We are now looking at question number 8, and we've been asked to find the minimum value of that particular function. So let's jump into it. Let's start by writing down the function y is equal to x cubed, and then x minus 4 is in brackets. So the idea that a minimum value means we know that y dash, or the gradient, will be equal to 0 at the minimum. So we need to get a gradient function to be able to use that information. So let's differentiate to get y dash. And before I do that, actually, I'm going to expand the bracket. So x to the power 4 minus 4x cubed. I'm now going to differentiate, so y dash will be equal to 4x cubed minus 12x squared. I know at that particular point that the gradient is going to be equal to 0, so I'm going to equate that to 0. So 0 is going to be equal to 4x cubed minus 12x squared. I'm going to factorize. I can see some x squareds in common and a 4 in common. So 0 will be equal to 4x squared, and then in brackets, x minus 3. My two answers, x1 will be equal to 0, and x2 will be equal to 3. So it does look a bit weird. Even though this is a cubic, it only has two answers. But what that probably means is there's going to be a point of inflection somewhere, and that x squared tells me that technically, this x1 answer comes up twice. So if there was a third answer, that third answer would be equal to 0. But we'll ignore that part. So we've now got the 2 points. We now need to figure out, well, are they maximums or are they minimums? And we figure that out by doing the second derivative test. So y dash dash, if we differentiate our differentiation, that's going to be equal to 12x squared minus 24x. Just a reminder, a positive second derivative tells us that we're dealing with a minimum, and a negative second derivative tells us that we're dealing with a maximum. So let's say y dash dash when x is equal to 0, that's going to be equal to 12 0 squared minus 24 times 0. That there comes to 0. So that there is actually a point of inflection, and that's what we discussed with that third or possible third answer earlier. Let's now look for y dash dash when x is equal to 3. That there is going to be equal to 12 times 3 squared minus 24 times 3. We're now going to go ahead and evaluate that. So 3 squared is 9. 9 times 12 is 108. And 72, so that's minus 72 over there. That there is positive 36. And that's what we were looking for. A minimum had a positive second derivative. So that means, therefore, this here is a minimum. We found the minimum. The only thing really left to do is you probably want to state it as a coordinate. So let's go ahead and find out. So we know the x value. Let's put that back into the original equation, find out what the corresponding y value would be. So we're now done here. So y will be equal to 3 cubed times 3 minus 1. That there is going to be 3 cubed is 27 times minus 1 is negative 27. So that means our minimum is 3, negative 27. And now looking at question number 9, and a chemical is slowly leaking onto the floor. The chemical spreads out from the point where it lands, and that can be modeled by a circle with a radius of r. At the time t seconds after the chemical leak is noticed that the radius is calculated in accordance to the time. Use calculus to find the rate of change of the area of the circle with respect to time when its radius is 10 centimeters. So first thing to note, rate of change, it's really nice to see that word in questions because that's code for find the gradient. And what we need to do now is we're looking at the area of the circle. So the first thing is we need to write down or come up with an equation of the circle in terms of time. So because r is equal to 0.1, I'm going to change that to a fraction because I like dealing with fractions. So that's 1/10 of t plus 2. We can substitute that in, and then we've got an expression or an equation comparing area and time. So that there is going to be equal to pi times 1 over 10t plus 2 squared. I'm going to expand that brackets just to make it easier for me. That's going to be 1 over 10t plus 2, 1 over 10t plus 2. We're now going to get into the actual expanding part. 1/10 of t times 1/10 of t is 1/100th of t squared. So t squared. And then we've got 1/10 of t times 2. It's going to be 2/10 of t, which is 1/5 of t. So plus 1/5 of t. Same again, plus 1/5 of t plus 4. That there, pi 100 or 100th of t squared plus 2 over 5 times t plus 4. And finally, a bit messy, I'm now going to expand the bracket to get pi out there. So that's going to be pi over 100 times t squared plus 2 pi over 5 times t plus 4 pi. So that there is my function for the area in relation to time. Because we're talking about the rate of change of the area, we're going to need to find a dash. And that there is going to be equal to 2 pi over 100 plus 2 pi over 5. And I can simplify that first one to be pi over 50. So that's going to be pi over 50. Oh, I forgot the t above. Times t plus 2 pi over 5. So that there is our gradient function. And the issue with this part is this equation is in terms of t, but we haven't been given any information about the time. The only bit of information is we've been told that the radius is equal to 10. So we know that r was equal to 10. And linking back, it's kind of hidden now, but linking back to our radius question, we can actually use that r value to find out what the radius might be. or what the time might be rather. So we know that 10 is going to be equal to 1/10 of t plus 2. So we're going to go minus 2 minus 2. So 8 is equal to 1/10 of t. We're then going to go times 10 times 10. T is equal to 80 seconds. So we know when the radius is 10 centimeters wide, that is after 80 seconds of this chemical leak going onto the floor. So we can now substitute that into our gradient function to find out the rate of change at that particular point. So we're now going pi over 50 times 80 plus pi, plus 2 pi over 5. And when you put that into your calculator, it's actually going to come out to 2 pi, or 6.28, and that had a 2 dp rounding. Units for these questions are probably the most annoying part, but just a reminder, so we're dealing with change of the area. So we're going to start off with by saying centimeters squared per, and you got to look at your other letter. T in this case was time per second, so per second. So what that means is for every 1 second, we would expect the radius or the area of the circle to change by 2 pi when the radius is 10 centimeters long. And for completeness, I should note, well, that was a 2 dp rounding. We are now up to question number 10, and we've got a function is defined by y is equal to 3x cubed minus 4a squared x plus 5, where a we've been told is a positive number. We've been asked to find the range of values for x in terms of a when the function is decreasing. I'm going to start off with by writing down our original function. So y is equal to 3x cubed minus 4a squared x plus 5. And we're dealing with when's it decreasing. Decreasing and increasing is to do with the gradient. So we're going to need the gradient function. So y dash will be equal to 9x squared minus 4a squared. We now need to think, well, how are we going to know when it's increasing or decreasing? And it changes direction at the turning point. So, for example, you've got a parabola, it's going down and then it's going up. So anything before the turning point is going down, anything after the turning point is going up. So to find out when stuff is increasing and decreasing, we've got to find the turning points and then have a look at what's happening before and after all those turning points. So the turning points, we know that y dash is equal to 0 at those points. So we're going to substitute that in to this derivative. So 0 is going to be equal to 9x squared minus 4a squared. Just a reminder, the question has specifically said in terms of a. That means we're not going to be able to solve this for an exact number. That means we're going to need to go x equals blah, 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 and that blah, 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 or has something to do with a in terms of an expression. So I can see that this here is actually going to be a difference between two squares question, because I can square root both of them and there's a negative sign in the middle. So 0 is going to be equal to 3x, which is the square root of 3x squared, minus 2a, which is the square root of 4a squared, and then in brackets, it's going to be the positive version of that as well. From that, we're going to come up and find our two solutions. So let's say if 3x minus 2a is equal to 0, 3x is equal to 2a, we're then going to go divide by 3, divide by 3. X is going to be equal to 2a divided by 3. So that would be our first kind of turning point, or our first x-intercept in the gradient function. Now we're going to do the same over here. So we've got 3x minus 2a is equal to 0. Plus 2a. We've then got 3x is equal to negative 2a. X will be equal to negative 2a divided by 3. So let's draw our gradient function. From here, we know it's a positive parabola. So it's going to look a bit like this, and we know it's going to have an x-axis, and our two turning points are going to be when the x-axis intercepts the parabola, and we're going to have negative 2a over 3, and we're going to have positive 2a over 3. So the questions ask us, when is this decreasing? And it would be decreasing when the gradient is negative or anything below the x-axis, in which case it's going to be anything between these two numbers. So when we're stating our final section, so we can say y, or function y, will be decreasing between -2 over a3, so when x is anything between those two values. Okay, we are now looking at question number 11, and we're talking about Meg is riding her motocross bike. When she passes a fixed point, so a fixed point is normally the giveaway that it's a kinematics question. It has a speed of 5. It has an acceleration, or she has an acceleration of 0.6. How far, so we're looking at distance, has she reached when she's got a speed of 8? So this question, you can tell, is going to be messy because you're dealing with the speed, the acceleration, and the displacement. So we're dealing with all three elements. So let's start off with, so there's our displacement. We need to differentiate that to get the velocity and differentiate that to get acceleration. If we're going in the other direction, we are integrating. So the only thing we know with certainty is we know the full equation for the acceleration, which is 0.6. While we know some information about speeds and velocity, we don't actually have the function. If I integrate this, so I've got the acceleration down here, I'm integrating to get to the velocity. The velocity, in terms of time, will be equal to 0.6 t plus c, and that plus c part's really annoying when we integrate. So we need to have a look for more information, but luckily we know it says down here, when she passes the fixed point, she has a speed of 5. So what that means is the fixed point is when we start. So that means no time has passed because she's at the fixed point. So that means the velocity would be 5 at that particular point. We're going to substitute both of these into our velocity function to find out what c would be. So 5 is going to be equal to 0.6 times 0 plus c. c is equal to 5. Therefore, our velocity, our full function, 0.6 t plus 5. We're now going to carry on a little bit. We've been asked about the distance. So we're now at the velocity. We want to go back to the displacement or the distance. We're going to have to integrate again. So s in terms of t is going to be equal to 0.6 divided by 1 plus 1, t to the power 1 plus 1 plus 5t plus c. That there is going to be equal to 0.3 of t squared plus 5t plus c. This equation here, if you remember, is about distance. So if 0 seconds have passed, how much have you traveled? In this case, the displacement will be equal to 0 because you can't travel anything if there's no time that's passed. So you are where you are. So we're going to substitute both of these in to find out that c value over here. So 0 is going to be equal to 3 or 0.3 times 0 squared plus 5 times 0 plus c. All of the zeros are gone, which means c is equal to 0. And that gives us a displacement formula of 0.3 t squared plus 5t. Just noting this 0, 0 in terms of the displacement is actually a really common feature that comes up in our exams. Good thing to remember. Okay, finally, we can actually answer the question now that we've got the equation. So we've got an equation of displacement in terms of time. We've been asked about when she has a velocity of 8. Annoyingly, velocity isn't a unit of time. So what we need to do is we need to deal with our velocity equation to find out, well, how long or what time will that be? So moving back over here. So we've got 8, which is the velocity we've been told about, is equal to 0.t plus 5. We're then going to go minus 5 minus 5. So 3 is equal to 0.6t. Divide by 0.6, divide by 0.6. 0.6. T would be equal to 5 seconds. So we know after 5 seconds, Meg will have a velocity of 8. which means we can substitute that into our displacement formula to find out how far she has gone after that time, or in 5 seconds. So the displacement in 5 seconds is going to be equal to 0.3 times 5 squared plus 5 times 5. Because there's decimals and squares, I wouldn't do this one step by step. I'll just bang it into the calculator. If you do that, you're going to get 32.5 meters. So that means she has traveled 32.5 meters when she got up to 8 meters per second. Okay, we are now on to question number 12, the final excellence question from this one. And just noting, this question did have a bit of a continuation from the previous question. And hopefully you remember that 8 meters per second was the speed, and she took 35.2 meters to get to that speed. So after this distance, so we're adding on an amount, Leo, who's Meg's friend, decides to decelerate. So they're going to start slowing down. If the deceleration is at this, or 0.2, how far past point T will be when he reaches a speed of 6 meters per second? So what we know, this deceleration is the acceleration formula, except it's going to be negative. So the acceleration is going to be negative 0.2. We know, so we've got displacement goes to velocity, goes to acceleration. We're going back to velocity, which means we need to integrate. So we know the velocity in terms of t is going to be negative 0.2 t plus c. This is where it gets a bit messy trying to find out the c value. So at the point where they start slowing down, that's our new fixed point, or our new starting point. So at that particular point, time is 0 because no time has passed when they're at that 8 meters per second speed. And at that point, we know the velocity that was given to us, that's equal to 8. We're going to substitute both of those back into the equation. So 8 is going to be equal to negative 0.2 times 0 plus c, which means c is going to be equal to 8. So that means our velocity is going to be equal to 0, or it's going to have an equation of negative 0.2 t plus 8. Now going to carry on to displacement, because again the question is how far. So the displacement in terms of time is going to be negative 0.2 divided by 1 plus 1 t, 1 plus 1 plus 8t plus c. It's going to get us to negative 1/10 of t squared plus 8t plus c. Again, we've got that annoying c value, so we need to figure out what we can substitute in to find out what that is. And again, because we're dealing with displacement, we know if no time has passed, so if t is equal to 0, no distance would have been traveled. So we can substitute both of those in to find c. Again, a real common theme for kinematics type questions. So 0 is going to be equal to negative 1 over 10 times 0 squared plus 8 times 0 plus c, which means c will be equal to 0. So our displacement equation is going to be equal to negative 1/10 of t squared plus 8t. Just a reminder, I'm dealing with fractions. If you prefer decimals, you could have done negative 0.1 of t squared. All right, now that we've got the displacement equation, like the previous question, we need a t value to substitute into that to find out how far they've traveled from that point. The only issue is, the other bit of information we've got is velocity, nothing to do with time. So again, we're going to yank out our velocity equation, and our velocity, or our known velocity, is 6. So 6 is equal to negative 0.2 t plus 8. I'm going to go minus 8 minus 8. That's a bad 8, but there we go. Negative 2 is equal to negative 0.2 t. I'm then going to go divide by negative 0.2, divide by negative 0.2. T is going to be equal to 10. So that's 10 seconds. And what that tells us is after 10 seconds, he will have a velocity of 6 meters per second. I'm going to put that back into this equation to find out how far they've gone. So we're going to put that into there. We're going to do that working over here, though. S in terms of t So S10 is equal to negative 1 over 10 of 10 squared plus 8 times 10. Because we're dealing with fractions and decimals, I'll probably bang that straight into the calculator, and that's going to get me an answer of 70. So that's 70 meters. But just a reminder, that's 70 meters from when they hit 8 centimeters per second to when he hit 6 per second, not from the original point. So we need to go, that's 32.5, which is from the original point, plus an extra 70 from the 8 velocity mark to the 6 velocity mark. We add them together, and that tells us 102.5 meters was traveled from point P before Leo hit a velocity of 6 meters per second. So pretty messy question, working shows that, but that wraps up all the excellence questions from the 2016 exam. Hopefully you found it useful. Keep an eye out for the other videos, and thanks very much for watching.